Hi, everybody. This is week one. Once you get past the Unit 0 orientation, we're going to be working on Unit 9 Advanced Array Concepts. So I kind of call this the hodgepodge chapter to wrap up where we left things off in the first course. So to begin, of course, you should read the different sections, and I highly recommend that you take some personal notes. It's not a good idea to just try to get through all the material um, by reading the assignments and trying to work backwards. So these really are a decent read. The chapter begins by talking about the bubble sort algorithm, where if you can imagine how bubbles go to the top of a glass in your pop, what the idea is that as we're sorting through things, we bubble the lower item up to the top until it gets into its final resting spot. So there's a critical explanation of something called a swap. It's very important that you understand how a swap works. It's very important that if you understand that if you want to swap two variables, that you actually need a third temporary variable along the way. So I highly encourage you that you read through that. Then there's an example showing how the bubble sort algorithm works. And there's also some discussion of improving bubble sort efficiency. Then moving on, we get introduced to the arrays class, and built into the arrays class are some algorithms that are available for you to use. Besides the bubble sort algorithm, there are some other algorithms as well called the insertion sort algorithm. And I highly encourage you to also read this. Basically, you look at each one element at a time, and if an element is out of order relative to any of the items earlier in the list, you move each earlier item down one position and then insert the tested element. So in other words, as you're processing elements in a list, if you find where it needs to go, you take everything from that point onward, shift it to the right, open a spot, and then insert that element in that location. Moving on after that, then we're going to get into two-dimensional arrays, which are really useful. They look something like this. So we're going to be introducing the idea of when you traverse an array, which means to go through the elements in an array, you not only have to worry about the position in the column, but also in the row. And in order to process elements in a two-dimensional array, like for example, if you wanted to print the elements in a two-dimensional array, you'd have to use two loops, an outer and an inner, and I'll show you an example of that. And I wanted to move on a little bit. We will also be introduced to an arrays class, which is a class provided with the Java language that has some built-in methods for you to do things like binary search, check if things are equal, and then sort. And the basic sorts in ascending order, and there's also another sort method that'll only sort certain elements of an array. So that's kind of an interesting concept. Then we'll talk about the array list class, which is a different data type that provides you a data structure that will grow and shrink as needed. So in other words, if we don't have to set a fixed size, if we remove something, the size will shrink and the gap in the array will be closed. Or if we need to increase the size of the array, that'll happen automatically behind the scenes if we add elements. So that one's really useful. The only caveat is that it can only store objects. Then finally, we're going to learn how to create our own data type called an enumerated data type. This was really interesting. I actually had never worked with this before, so I played around and gave you an example. So I'm going to start first by providing you some code for the bubble sort. I use a tool called JGrasp in my code. So as I was mentioning, to process an array, so if I have a method called bubble sort where I'm passing an array, notice I have an outer loop and an inner loop. And then we're checking consecutive elements in an array. So this might be position 1, this might be position 2. It's one greater. And if what's in position 2 is greater than what's in position 1, then we're going to want to sort those elements of the array. So we're going to want to put the bigger one where the smaller one is. And so we use a swap algorithm. Now, also when we're, and then we have a method to print out the array. So here's our array. And when we test it, you'll see that this array will then go to a sorted order. I also have an example of a two-dimensional array. I have a couple different things. So like with regular arrays, you have to tell Java how many rows and columns. So the first number you see is a row. The second number is the number of columns. So 5 rows, 10 columns. And as I was mentioning, you have to use an outer and an inner loop to process the elements of an array. We often use row and column as the counting variables because they make sense for a two-dimensional array since you're processing by rows and columns. To access the elements of a two-dimensional array, you should use both a row and a column element. Here's an example of you populating elements of the array or loading the table with values. To print elements of a two-dimensional array, again, you have to use an outer and an inner. Notice that the number of rows is given by the name of the array .length, but if you need to know the number of columns, you have to do it a little differently. You basically have to pick a row, table of row, and then we can use the .length constant. You can use an initializer list to populate an array. So this is going to make an array that has 2 rows and 13 columns. And this will show you what it looks like when you print it out again. So we can make arrays of ints. We can make an array in arrays of strings. We can make arrays of any data types, but we can only use the same data type for arrays. Now the last thing I wanted to talk about is, and I actually have 2 things in here. I have an enumeration example where I make my own data type, and then I have a sorting example. So the first things first, when you make an enumeration data type, it has to go outside of your class. So notice I personally just put it between my import statements and where my class begins. So you use the keyword enum, you give it a name, and then inside of these curly brackets, you include all the elements of the data type. And notice that we do them all in caps. And we're going to use that a bit later. Now, we're going to go ahead and show you how we call the sort from the arrays class. So here I've created a string array of different fruits, and I'm going to print it out using a for each loop before a sort. To call a sort, it's very simple. Just use the name of the class array. So this is a static method, and then we say .sort, and then inside of here, we use the name of the array. So we're going to sort the array fruits, and then I'm going to print it after sorting. Now, let's take a look at the enumeration example. I originally was going to pick a random card, but I no longer am going to do that. So remember, I've already populated my data type with the 4 types of suits for cards. So I'm going to print that. And to print it, I say the name, the type, the name of the enumeration data type is suit, a value, and then for every value in suit, I want the values. So this should print those hearts, diamonds, spades, and clubs. Now, then I'm going to ask somebody to enter in a suit by name, so a string, and then I'm going to ask for the value of the suit, and then I'm going to want to know its position in the enumeration, and these positions work like an array, 0, 1, 2, 3, and then print it out. So let's go ahead and run that. So you see the array, unsorted array, the sorted array. Notice when we sort strings, we sort them lexicographically or in alphabetical order. And then here is what we see for the enumeration. We might enter hearts. And we print the value of hearts at position 0. Thank you.